Okay, so this is still SIG 3006 stratigraphic methods, and today will be lecture number 6. Yeah, but I'll just give you a recap here of what we've learned up to now. So we've looked at the interaction between we've looked at the interaction between uh, relative sea level change and sediment supply. And depending on the interaction, you get different patterns to the stratigraphy. And in the single sea level cycle, you get a certain pattern to the stratigraphy, which is bounded by unconformities, right? So you have these sequences. And these sequences are bounded by unconformities, and you can divide them into several systems tracks, right? So you have a falling stage, a low stand, a transgressive systems track, and a high stand systems track. During the practical, I'll show you that the easiest ones to identify are the LST, the TST, and the HST. Sometimes you can get the FSST preserved, but sometimes it is also too thin to be observed on seismic sections. Okay. So that's the pattern that we've looked at, right? HST, LST, TST, HST, and the cycle continues. And you have these key stratigraphic surfaces, sequence boundaries, transgressive surfaces, maximum flooding surfaces, right? And then your parasequence sets form certain patterns depending on the system's track. It is prograding to aggrading for the LST, retrograding for the TST, and aggrading to prograding to degrading erosional APD during HST. All right. So we've looked at the stratigraphic pattern of these systems tracks on the shelf, right? We've looked at the shelf mostly. That was what the previous lecture was on, just the stratigraphic expression of systems tracks on the shelf. So where you have things like coastal plain, deltas, shore faces, and so on, right? So now the next step, the next thing we need to understand is how does sequence stratigraphy look like in deep marine environments? Is it going to be the same? It's going to be slightly different. You can identify the system tracks, right? But the type of sedimentary fascies that is going to be preserved is going to be different, and the pattern is a little bit different, and that's what we're going to look at today. Okay, so that was the recap. Now let's continue and look at deep marine sequence stratigraphy. Everybody can see this slide? Nampak ya? All right. So let's look at sequence stratigraphy in the deeper parts of your basin. We've been looking on the shelf here. I'm not showing it, but it's going to be here. So you get things like prograding deltas during the low stand and high stand, retrograding deltas, incised valleys on this side. Let's move further seaward towards the shelf edge and the shelf break here. And then you get the slope. You have the slope with a steeper angle to the slope here. And the slope then becomes gentler again and goes to basin plane, right? So you've learned this before, passive margin continental shelf, right? So let's look at the interaction between relative sea level and sediment supply during different phases of relative sea level change. Yeah? Okay, so during the falling stage systems track first. If you remember the sea level curve, the sea level cycle there, and so this is going to be the start of the falling limb, right? It's going down very rapidly. We have a steep curve, so going down. The sea level is falling very, very fast. And because of that, the shoreline is moving further and further basinward, right? Shoreline was here but then sea level falls, goes down, sea level falls and goes down. Sometimes your sea level can fall down below the shelf edge. And those are very dramatic sea level fall. And because of that, you get forced regression. Okay. But yeah, okay. So you have this slope basin. Now, before going to falling stage systems track, of course, you start with an earlier HST kan. So you had an earlier HST, and during the HST, remember, that was you just went through the highest sea levels, right? Sea level was rising during the TST, then you get the maximum flooding surface, right? So sea level probably somewhere here, if you can imagine it, yeah. So at the HST position, shoreline is still far from the shelf edge, somewhere here, not here, right? So this is very far away now. Okay. But it is moving further and further basinward, lah, right? Okay. Because of the forced regression. Now, because of this lowering in sea level, you also get what is called a lowering in wave base. So you remember back to sedimentology lectures, right? You have wave base, and below wave base, the waves cannot influence sediment transport and deposition because it's too deep, right? It does not touch the bottom. But because sea level has fallen here, the wave base is also falling. It's getting lower and lower and lower, and this results in instability. What was once deep water, relatively deep marine here, is now much shallower. So the waves are eroding. Yeah. So you get sediment erosion and reworking around the shelf edge. So lots of sediment is being moved here and there, and some of it is accumulating at sini. It's going to end up here, and it will build up, and that can result in instability. And the slope can become steeper and steeper, and what you get is a slope failure. And sediment can actually move down along the slope towards the basin plane. All right. All right. Another thing, the eroded HST outer shelf, the outer shelf here is going to be fine grained because most of your sand is going to be trapped in the deltas, and that is still very far away. Right? So it's going to be mostly fine grained. So what you get being transported downward is mostly gravity flows in the form of debrides because there's a lot of mud, and also you get lots of slumps on the slope itself. And these debrides can reach the basin plane to form these very extensive deposits, right? So these debrides will be sharp based and will have an irregular top. Lots of topography here. Okay? So I'm 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 marking the debrides here as MTD. It means mass transport deposit, but you don't really need to remember that name. So this is just debrides. Yeah. Okay, so forced regression, sea level is going down, shoreline is moving further and further seaward, but it is quite far, still far away from the basin center here. It's very muddy here, so more and more sediment accumulates along the shelf edge, and it goes down the slope as a gravity flow, mainly in the form of debrides. All right. Okay, so that is the early phase of the falling stage system strat. Later on, during the falling stage, there's still forced regression. Now, the deltas will be nearest to the shelf edge now. It has prograded, regress the shoreline. It reaches here now. All right, reaches here. Because now the delta is here, a large amount of sediment can be transported to the deep water. Rivers are moving, reaching the shelf edge until here. You can have sand, and the sand is being transported down the slope onto the basin. Okay. Okay. So a large amount of sediment is transported to deep water. There's negative accommodation space now on the shelf. Everything is now exposed here, and that can be eroded, and that can be transported towards the basin floor. So get negative accommodation space, no space basically, right? So erosion, and you get deposition of high density turbidites. So yeah, those turbidites will be moving down the slope here and be deposited here. They're going to be very sandy, right? So you got the Bauma divisions of Bauma A and Bauma B being dominant. Okay, so you got the high density turbidites being deposited during the late falling stage system strat. Turbidites are more fluid, right? They are turbulent flow compared to your debrides, and debrides are laminar flow, right? They're more viscous, right? So they can travel farther compared to your debris. So in this case, the position of the debris is farther than the debris here. Okay. Okay, so that is the falling stage system track. Sea level is falling down, shoreline is regressing towards the sea, and because of this, you have sediment accumulating on the shelf edge, and these sediments can collapse and transported downslope as gravity flows, debrides and also turbidites. Yeah? Any questions so far? Okay, so if no questions, we move further on. So this was the falling stage, right? Your sea level is falling down rapidly. Then you reach the lowest level of sea level, right? So you reach the low stand systems track. Okay, sea level is now starting to rise, but very slow, right? Climbing a little bit, and the curve is very gentle in terms of angle. So what you get during this time is normal regression. It's no longer forced regression, and you get a slow rise in relative sea level. So you have accommodation being created, okay, more and more space for sediment to fill in. Uh, and during this time, coarse sediment is going to be mostly trapped in your alluvial valleys because you had incised valleys being formed during the falling stage, right? At the incised valleys. And these can be filled in with lots of coarse sediment, sands, and gravel. So they are trapped on the shelf. So most of the sediment that reaches the basin floor itself during the LST is going to be finer grain. So you get low density turbidites. Maybe you get complete Bauma sequences from TA to TE, or just very thin mud dominated turbidites from TC to TE. I hope you remember your Bauma sequence divisions. Huh? So TC is you have ripples, right? And it's going into lamination and shale at the top. All right. So yeah, you have gravity flows going down the slope, and the slope just becomes a bypass area, like a highway. The sediment just moves across it. It doesn't. Most of it is not going to end up on the slope. It's not going to be deposited here. So finer grain turbidites, you get smaller lobes and more distal lobes here, and you can also get the development of levate channels. You have submarine fans with channel levees, betul kan? And because this is because the sediments are mainly fine grain, which are reaching your basin plane. Okay, everybody can still hear me. Yeah, I wasn't disconnected. Yeah.
Can,
Okay.
Doctor.
All right. So that was part of the low stand systems track. Okay, low stand systems track tadi. Yeah, and the pattern is supposed to be prograde to aggregate, just like you see on the shelf, right? So here, first is prograding, right? Towards the front, then it starts to build up because of relative sea level rise. Now, during the transgressive systems track, sea level rise will be dramatic on the shelf and on the slope, right? So also in the deep marine area, you get the same kind of pattern. You get retrogradation. During the early stage, some low density turbidites, they can reach the basin. So it's falling down here, goes onto the slope, and your turbidites can reach the basin. Because you can still get deltas near the shelf edge, and there is wave erosion. Okay, but later on, the shoreline will move further and further backwards, yeah, because it is retrograding. This is because during the late stage, yeah, you have very high sea levels, and during the late stage, this results in the domination of mass transport deposits. You start to get debrides now being deposited because the shoreline is now very far away from the shelf edge. So it's going to be very muddy here. So you get slope failures and you get lots of debris flows and slumps. Right? Okay. So yeah, you still get submarine fan deposits, and they are retrograding towards the back here. Okay. Don't please ignore this part here. This healing phase here. This is a slide from the master's course, but yeah, just take note that your turbidites, your submarine fans, will be retrograding during the transgressive system strike. Okay, so when you reach again the high stand, the period of the highest sea levels, right? And sea level is starting to slow down again, but very slowly, right? Shoreline is very far away from the shelf edge. So it's so far away that uh, most of the sediment cannot reach the deep marine part. Okay? So you don't get significant gravity flows, right? Uh, Not much in terms of turbidites. You maybe probably get just a very thin layer of hemipelagic deposits, just lots of shale, right? So pelagic sedimentation and hemipelagic sedimentation will be dominant, and you get what is called a condensed section associated with the maximum flooding surface. So I don't even mark it here because it's going to be very thin, because the shoreline, the deltas are very far away from your slope, and if there are any sediments, it's going to be deposited on the shelf. So in terms of sequence stratigraphy, ideally this is what you are going to get on the basin plane itself in the deep marine area. So it's a little bit significantly different compared to what you see on the shelf, right? So no more things like deltas or shelf deposits or incised valleys and so on. You get another kind of pattern. So you have three deep marine sequences. One from here to here, two here to here, and three here to here. And they are bounded by sequence boundaries here. Okay. So what you get is these relatively fining upward sedimentary successions. Yeah. So you go from debride at the bottom. So this part of the FSST and also the early part of the LST. Then you get debrides here. Sorry, the FFST. And then you start to get sandy turbidites being deposited during the low stand. But your turbidites become finer and finer grain during the TST, and debrides will become dominant again during the TST because you are far away from the river supply. And during the HST, the sedimentary succession is going to be very thin. It's going to be a condensed section. It's mostly just pelagic deposits and hemipelagic deposits. Lots of clay, maybe even some aeolian clay and ash mixed together with plankton, things like forams and nanoplanktons, um, and so on. Okay, and even radiolaria. All right. And when the cycle continues again, you have another sea level fall. But notice, right, here, our sequence boundary is not an it's not a subaerial unconformity. It's not a subaerial conformity. When we say subaerial, we mean that it has been exposed to the atmosphere, but everything here is underwater. It never is exposed because it's too deep, right? So yeah, you get correlative conformities here. Abrupt shift in fasces, right? But it's not really an unconformity, right? It's a correlative conformity. You can correlate it to the unconformities on the shelf itself. All right. So when the cycle continues again, falling back down, falling stage, you have the debrides. Uh, Low stand, you get the turbidites, and also during the TST, you get more debrides, followed by a condensed section dominated by shale, and the cycle continues on and on. All right. So yeah, today is quite brief. Just the final part of sequence stratigraphy need to talk about. Okay, so going back here. So that is what is happening. So we've looked at this part, right? So you get a different kind of package compared to here. Okay. All right. So any questions? You have lots of time, so you need any places which you want further clarification, want to make it clearer, or even questions for the previous lectures if you don't understand something. Okay, so no questions. Let me see apa lagi saya tak sebut. Alright, so another important thing, right? So we've already started practicals on identifying pair sequences, right? We've been doing practicals on identifying pair sequences. Let me get a nice slide to show you. Okay, pair sequences like this, and so you have these shallowing upward successions, things like going from offshore, low shore phase to upper shore phase, or going from pro delta, delta front, and so on, right? And there you can find these kinds of patterns, things like aggradation, progradation, and retrogradation of your parasequence sets. Now, I need to emphasize this, yeah. Um, these parasequences are, are only identified on the shelf. Okay, so in deep marine settings, you don't get these nice shallowing upward sedimentary packages. So remember that. So when working on sequence stratigraphy in deep marine areas, we don't usually talk about parasequences. Okay. So if it is turbidite, we don't really usually talk about parasequences. If it is delta or shoreface, we talk about parasequences. Right. So you get submarine fans and lobes on the deep marine areas, but usually we don't talk about parasequences because usually the sequences are very thin. Okay. All right. Apa lagi? One more thing. Can I ask you, have we done the discussion for this practical? Saya tak ingat yang ni.
Dah, Doctor?
We've already discussed this, right?
I think so, yeah.
Betul, everybody can confirm, ya?
Dah, Doktor. Dah.
Alright, okay. So we don't need to repeat this one. Okay, so if any questions then?
Just now yang kita belajar pasal the deep stratigraphy tu, so far in all the practicals, do we have like examples of those sequences in our logs?
So far, no. So far, we've been looking at the shelf, right? Uh, so there will be practicals later on. I'll show you how to do sequence stratigraphy in deep marine areas, but using seismic.
Okay.
Okay, so that'll be after the mid-semester break.
All right. Will the lecture notes be uploaded after this?
Yes, will be uploaded after this.
Okay.
All right. Any other questions?
I'm good, Doctor.
Okay, so no questions yet. So in that case, we'll end early today, and I'll see you at the practical on Wednesday.
Thank you, Doctor.
All right.
Okay,
Thank you,
thanks.
Doctor.
Thank you, Doctor.
Thank you.